The birth of a next-gen combat drone begins deep within the Earth, extracting the rare alloys required for supersonic endurance. Every grain of raw material is purified, ensuring the structural perfection needed for high-G combat maneuvers. We forge the building blocks of stealth under extreme heat, creating carbon composite fibers stronger than aerospace steel.
These carbon fibers are the DNA of the loyal Wingman, lightweight, durable, and nearly invisible to radar. Starting with the highest quality composites is how we ensure the Wingman outpaces any adversary in the sky.
Ultrasonic precision ensures every composite layer is cut to within a fraction of a millimeter for aerodynamic perfection. Intense pressure creates the titanium backbone of the drone, capable of withstanding the heat of supersonic flight. Quality control is absolute. Even a microscopic impurity could compromise the aircraft's structural integrity at Mach 2. Thousands of tons of material are managed by a digital logistics brain, feeding the assembly line 24 hours a day. The materials are ready. Now, they enter the most secure manufacturing complex in the defense sector. Moving these strategic assets requires a secure underground artery, shielded from all external satellite observation. Every load is scrubbed and scanned, ensuring no external contaminants enter the clean room environment of the assembly core. In the digital age, logistics is as critical as firepower. Every component must be accounted for by the millisecond. Speed and efficiency define the movement of parts, minimizing the time from raw material to combat readiness.
These materials are now entering the inner sanctum of the loyal Wingman manufacturing facility. Beyond these doors, the aircraft's indestructible shell begins to take its final physical shape. Every second of transport is optimized through a fully automated, AI-driven logistics network.
Protection starts before the first weld, preserving the purity of the aerospace-grade composites. Total visibility ensures the security of the supply chain, preventing any deviation from the build protocol. The materials have reached their destination. The transformation from carbon to autonomous warplane is now imminent. The production center is a fortress of rapid manufacturing, a hyperscale facility designed to build the future of air dominance. Every entry is a digital filter, ensuring that only authenticated components reach the heart of the autonomous assembly line.
Security here isn't just a gate, it's an AI-driven ecosystem that tracks every movement in real time. Beyond this point, the factory floor becomes an extension of the aircraft's own digital nervous system.
Security and software are inseparable, creating a closed-loop environment where every asset is accounted for by the millisecond. We monitor the facility's vitals through a centralized OS, ensuring absolute stability for the high-precision tasks ahead. Each zone is a controlled environment, protecting the manufacturing precision required for high-altitude endurance. Purity is essential. At these speeds, the smallest surface imperfection can disrupt the aircraft's stealth profile. Total visibility ensures that the production blueprint is followed with zero room for deviation. The gateway is closed. Now, the manufacturing heart of the facility begins to forge the next generation of air combat. Extreme pressure at the heart of the facility forges the structural backbone required to withstand 9G combat maneuvers. Precision at the speed of light, shaping the internal architecture that will house the drone's autonomous brain. Every curve is sculpted to a micron, ensuring the modular subsystems interface perfectly with the airframe.
Ultrasonic cutting allows us to shape advanced composites without compromising their molecular integrity. Maintaining structural strength while reducing weight is the secret to the Wingman's unrivaled performance.
Controlled heat cycles ensure these critical stress points can withstand the violent force of high-speed landings. Every component is an authenticated data point, ensuring total accountability within the autonomous supply chain. The human touch provides the final layer of perfection, refining the work of the machines for a flawless aerodynamic fit. We eliminate internal stress at the molecular level, ensuring the airframe remains stable under extreme G-loads. The components are carved, the alloys are hardened. Now, the structural assembly of the Wingman begins. The airframe is unified, a rigid, lightweight titanium shell built to endure the brutal physics of autonomous combat. Precision at this scale requires absolute control, rotating the aerospace architecture for millimetric alignment.
This internal skeleton is the foundation of high-G flight, engineered to maintain its shape under extreme aerodynamic pressure. Every structural rib is a masterpiece of weight reduction, ensuring the Wingman remains agile and nearly invisible.
Structural synchronization ensures the aircraft's profile is perfectly shaped for maximum aerodynamic efficiency and radar deflection. We lock the tension of every control mount to a global standard, ensuring a lethal response in the heat of combat. The modular bay is the drone's tactical heart, allowing for rapid mission reconfiguration between sorties.
Initiating global symmetry check on the chassis. Laser grid is tracing, readings are stable. Tail alignment confirmed within 0.05 millimeters. We are ready. The chassis is complete. Now, we install the electronic nervous system that will drive the autonomous Wingman of tomorrow.
The autonomous brain is seated, capable of processing millions of combat variables per second without human input. High-resolution digital eyes allow the Wingman to track and identify multiple targets across vast distances.
Our navigation systems are hardened against electronic interference, ensuring mission success in contested environments. Absolute precision is what makes this drone the most reliable Wingman a pilot can have.
Fiber optics form the high-speed nervous system, ensuring zero-latency communication between every sensor. A digital shield is raised, providing the Wingman with the electronic dominance to operate in high-threat zones. The heart of the control system, converting digital commands into physical movement at the speed of thought.
Initiating global system sync test. Connection established. All systems self-testing. Clear.
We synchronize every digital heartbeat, ensuring the aircraft operates as a single, unified entity.
Accessing the internal power vault.
Module locked.
Self-contained power is essential, providing the energy required for long-endurance autonomous missions.
Initiating final data handshake. The system is now online, the brain is awake, and the Wingman is ready for its final structural unification.
Automation at this scale ensures absolute symmetry, merging the Wingman's brain and body into a single aerodynamic entity. These robotic welders create an unbreakable bond, ensuring the airframe survives the intense G-forces of autonomous combat.
We use AI-driven thermal monitoring to prevent any microscopic warping during the high-speed welding process. Consistency is the key to stealth. Every weld must be perfectly flush to maintain the Wingman's low observable profile.
The system's steering is seated, the most responsive and accurate control surfaces in the autonomous arsenal. Modular assembly allows for rapid repair and upgrades, ensuring the Wingman evolves alongside the software it carries. We seal the interior from the elements, ensuring the AI core and sensors remain operational in any climate. The final layer of connectivity, a secure link that allows the Wingman to receive mission updates from human pilots. Aerodynamic drag and radar return are minimized through engineering, allowing the Wingman to haunt the edge of contested airspace. The structure is finalized. The Wingman is whole. Now, it must receive its tactical hide and stealth finish. Surface preparation is a precise science, ensuring the multi-layered stealth skin bonds perfectly to the aircraft's frame. We apply a molecular shield, protecting the sensitive AI core from the static electricity generated at transonic speeds.
Our tactical finish is a complex polymer designed to absorb enemy radar energy rather than reflect it. Modern visibility is a coating, ensuring the Wingman remains a ghost on the enemy's long-range sensors.
The tactical skin is engineered for survival, allowing the Wingman to penetrate the most advanced integrated air defenses. Heat locks the stealth identity in place, ensuring the coating survives the friction of high-altitude combat. Thermal management is integrated into the finish, protecting the airframe from the heat of its own velocity. Every Wingman is an authenticated asset, tracked digitally from the assembly line to the combat theater.
Absorption is 99.9%, stealth pass confirmed. Proceeding to durability testing and fastening descendants, ensuring the aircraft meets the rigid requirements of stealth flight.
The hide is complete. The Wingman is dressed for war. Now, the machine must prove its resilience in the simulation.
We subject the airframe to extreme acoustic stress, ensuring every internal electronic bond remains intact during high-G maneuvers.
From the freezing edge of space to the friction heat of supersonic flight, the Wingman is engineered to remain operational.
Lethality is verified in a digital vacuum, ensuring the AI autopilot outmaneuvers any modern kinetic threat. Our autonomous systems are hardened against the most intense electronic warfare environments. A precision strike is only possible if the AI can think through the digital noise of the modern battlefield.
The system is hermetically sealed, protecting the sensitive processors and fuel systems for long-endurance missions. Hardened against the unexpected, the Wingman maintains its mission profile even under direct electromagnetic interference.
Initiating weight and balance test. Lift sequence engaged. Center of gravity aligned, balance verified within spec. Calibrated, sticker applied, Wingman is stable. Initiating final power-up test. Batteries active, all sensors and actuators powering up. Energy management is verified, ensuring the AI has the power to finish what the mission demands. Mission capable. Tested, proven, perfected. The transition from raw carbon to an Apex AI warplane is complete.
In the final hour, perfection is the only acceptable result for a masterpiece of autonomous aerospace engineering.
Lubrication confirmed, dispatch is ready.
Every moving part is primed for endurance, ensuring the journey from factory to flight begins with total protection.
Initiating transport to storage.
A strategic inventory ready for rapid deployment, supported by an environment that stops the clock on material aging.
Drive is ready for transfer, biometric confirmed. Confirmed. Digital twin log secured, code Alpha SAS7. Receiving, code Bravo 9. Case locked, acknowledged, following.
The transition is complete, from a static assembly of carbon and code to a mobile asset ready for the theater of operations. Every Wingman dispatched is a tribute to the thousands of hours of precision engineering that forged it within these hidden walls.
And this is how modern defense factories build advanced systems from start to finish.
Connecting engineering, moving the industry, and defining the future of global defense.